Question 3 says explain why the headlamps of a car go dim when a starter motor is used. So we're going to represent the cell. It's going to be a battery, so I might put a few cells together like this of our engine, of our car, sorry, and it's connected in one part to the starter motor. This is a circuit that we want to be able to switch on and off, so let's put a switch in, and also to the headlights, which I'm just going to represent with a single bulb. We can probably also put them on like this. So we've got an on-off switch on the light bulbs. And then this question is about internal resistance, so I should probably put an internal resistor in as well. So something like this. And to answer this question, one of the key ideas is that the bulb can have quite a high resistance, and therefore it draws a low current from the cell, but that the starter motor has to have a very low resistance, and the reason for that is because it needs to take lots of energy from the cell, so it needs to draw a large current from the cell. So why the headlamps of a car go dim when the starter is moved. So when it's just the headlamps on, which it seems to imply at the start of the question, the lights in the car are on, but the motor's not currently turned on. Just the headlamps. The bulbs draw a small current, so the lost volts, which remember is lost volts, which are calculated by I times little r, are small. The terminal PD of the cell, that's calculated E minus IR, is very close. Well, I can't spell very close to the EMF of the cell. When you turn on the starter motor, a large current is drawn from the cell. That means the lost volts, which remember is I times R, is no longer insignificant. The terminal PD drops. Oops, we can put that in. Terminal PD, which is V is E minus IR, drops and is much less than E, comma, so now the lamps have a lower PD across them, which means they get dimmer.